In this video, we're going to show you how to run UAV images through the Imagine UAV process. This interface is installed, and the corresponding layout from Geosystems is installed when you install the Imagine UAV add-on module. So once it's installed, you get this toolbar here that is accessible when you use the Geosystems layout, or you can go to the toolbox under the regular layout and access the UAV options there as well. I've actually put it on my quick access toolbar for a couple of the functions that I can use, so you can do that as well. This will allow you to process images from UAVs on ERDAS Imagine Essentials, Advantage, or even Professional level of Imagine. So at all three levels, at the Professional level, obviously you have the advanced spatial modeling capabilities, which I'll show you here in just a sec. So the easiest way to start this off is just to run UAV process, and there's not a lot of sophistication needed in the input options here. We can dial into the outputs later, but basically you just specify your input folder, and you have this small project folder defined here. You specify the kind of images that are in that folder. So in this case, JPEGs are pretty standard JPEG collection for UAV images. Or if you were to have TIFFs or something else, you would just do start.tiff. You would specify if the orientation format is from an EXIF data, which is typically embedded in the JPEG data itself, or you can have computed or recorded from the iBotics UAV sensors. If you have an external orientation input file, you would specify that here, and if you're not sure what format that orientation file is in, or if it isn't in the correct format, you can use this edit orientation formats dialog here, which just basically allows you to recreate the actual file so that it adheres to that interior orientation file that we need. So if we go back to the spatial model GUI, then we get down to the orientation accuracy. I usually set this to low just to start off. This basically just means the orientation accuracy is low for now, and when we do the final run, we'll obviously make it high. And the same thing with the surface accuracy. The reason for putting these at low to start with is it runs much quicker, and we're not as concerned with the accuracy at this point until we run the high accuracy and kind of the slower the processing engine. Next we get to the EPSG zones. I know this happens to be in the Atlanta area, so Zone 17, UTM Zone 17, EPSG code is 32617 for WGS84. That's pretty easy to find out what EPSG zone your imagery is in. Just a simple lookup. It does produce three different file outputs. A mosaic file, call it MOS. It produces an LAS file, call it LAS. And it produces a DSM file, call it DSM for output. So if you didn't want one of these outputs, you would have to go in and change the spatial model itself, but it's going to produce these three outputs from all the images in the set. So from this point, you could then run it in batch to run it later, or distribute it across multiple machines if you wanted to, or you can just hit run right now, and we can also preview the option if we want to. What I'm going to do is move on to the view model operation. So if we click on the view model for that, we can see here we have the actual model that's defined. It's kind of working in the background of that GUI, and so if I wanted to, I could just very easily remove a couple of these functions, add, remove, replace, whatever you want to do. We can very easily do that. So what I'm going to do actually is add just a preview option to this, just to show you how easy it is to output something or add something onto this and modify this spatial model. We do have to make sure that our image directory is set. So again, just specify this small directory, small project, and I might want to change some features like the accuracy, like I said. I keep it at low just so that it runs quick, so for the convenience of time. And we also need to define an output file. Call it tempi. And then the EPSG zone, like we said, we have to make sure that that's set to the right area so that it actually runs for the plates that we want it to. So now, when I hit the preview button, it runs through and should fire up a viewer and the image that is the preview image to go along with that. This should just take a few seconds because we've got to process that low resolution. It'll produce an output file, which we can actually do a little bit with. But the preview image is actually, there's not a lot to it. So if we look at the preview options, we can do a few things like change it to the elevation and get a good idea as to how that point cloud was output. But at least we know that it is, it's creating that UTM zone like we specified. Look, if you look at the bottom of the screen there, you'll see UTM zone 17 just like we want. So it's geocoded correctly, projected correctly, and it has elevation values based on the color by, the ramp by. So again, this is just a preview option, so it's not an actual file created yet. So we want to, at this point, we might want to run this file and create that actual that temp file the actual file output. I'm going to kill this and not save my changes, and just open up a couple of viewers to show some of the output results. So open point layer, so I have a low resolution LES file, and then I also have a higher resolution LES file, just so we can kind of see the differences between them, which you can probably see is a little bit more there's a little bit more detail obviously in the high resolution. As we zoom in, we can definitely see that in the low resolution last file obviously gets it does get kind of filtered out a little bit. But that's okay. If we wanted to, we could even bump up those points to kind of mimic what the high resolution looks like, but we're going to leave it as it is. If I add an additional viewer, we can kind of take a look at the DSM that's created from that. So let's go to the DSM, high resolution, load as a relief layer, so we can kind of take a look at that. There you have it. If we zoom in here, we can kind of see the features of the mounds that we're kind of looking at here. And then we can also open up the mosaic layer on top if we wanted to, just to kind of show how the mosaic looks from that. And you're actually looking at the mosaic on the left there as well, on top of the. Oops, put it in the wrong viewer. So just put this layer to window and put it in this view over here. And there we have it. So zoom in and take a look at all the imagery. And then also, if we wanted to, look at the point cloud itself, and in a 3D environment, go to UAV, open the point cloud layer, open the high resolution last file. That turns on or activates our point cloud options, which when we click on 3D, show in 3D, loads up here really quick, and you can kind of zoom in and see those results. And there you have it. Spin around here and see these different mounds. And that should be a good little example of how to use the point cloud tools, the spatial model environment, and how to add things onto the spatial model and run the Imagine UAV process.